Akwaba, welcome to the Math Classroom. If you are new to my channel, kindly don't forget to subscribe, like and share the video. To my already subscribers, I'd say Aiko. Our lesson today focuses on equations with homogeneous coefficients. In our previous lesson, we were looking at solving differential equations, and the first method we looked at was separation of variables. If I have a differential equation of the form this, so this actually is a differential form. So this is a differential form. And we are saying that this differential equation is homogeneous. So this becomes homogeneous if the functions, so these two functions, so this function and that function are also what? Homogeneous. That is if m of xy and n of what? Xy are also what? Homogeneous what? Functions. What do we mean when we say what? They are what? Homogeneous. Okay, so they are not just homogeneous, but both have what? Same what? Degree. Both have the same what? Degree. Okay, so this is our differential form. If I want the standard form of my differential equation, so let's say in the standard form, then you have y prime to be equal to f as a function of what? X and what? Y. So this will be my standard form and this will be my what? Differential form. Okay, and with this, then you realize that with this a differential form, it depends only, so depends only on the ratio. So you have the ratio y over what? X, or x over y. Then we can also see that it is what? Homogeneous. So let's find out, when we say a function is homogeneous, what do we mean by that? Okay, so we said m and x should be what? Homogeneous. So that if I have a function, let's say a function, this is our function f of x, that is with two variables, is homogeneous. It's homogeneous if there's a constant, let's say homogeneous of a certain degree, let's say degree n, if there's a constant, there is a constant such that I can write my f at lambda x, lambda what? Y, to be equal to lambda of degree n, f of what? X what? Y. Then the function is what? Homogeneous. So what does it mean from our previous lesson where we had the two functions? I had m of what? X, y, So what it means is that wherever I see x, I replace with what? Lambda what? X. Wherever I see y, I replace with what? Lambda y. So that if I have, this implies that I have what? M lambda x lambda y. If I'm able to write this in a form of what? Lambda to a certain degree n, where I still have my function what? X what? Y. Then the same thing for my n x y as well. Then I can say that these two functions are what? Homogeneous. And if these two functions are homogeneous, then the differential equation I'm looking at is also what? Homogeneous. Okay, so this homogeneous equation we are talking about, it's used in solving what? A differential equation. So from our previous lesson on the method of separation of variables, if it is not separable, so if it is not separable, so let's say the differential equation I have is not separable, then I can actually check, the next step I could use is also to check if it is what? Homogeneous. And if it is homogeneous, then I can use the method of what? Substitution. What is the substitution we are talking about? The substitution is that wherever I see y, we are saying y is going to be equal to what? Xv. Okay, then I have the y to be equal to, so the y, let's say the y over the x is equal to v plus x dv. Okay, or simply you have the y or simply you realize that you have from here, you have the y to be equal to x dv plus v dx. So we use this substitution to solve, but you first have to check if the equation is what? Homogeneous. And if it is homogeneous, then I can use this substitution to solve for my differential equation. In our next lesson, we'll look at examples on solving homogeneous differential equation. Till then, kindly keep safe. Thank you.